Hey people, and welcome to this video. In this video, we'll be working on the grade 12 Mathematics Paper 1 for November 2023. This paper is 150 marks and the time allocated is 3 hours. Okay, looking at the instructions, just remember to round off to two decimal places unless stated otherwise, and the diagrams are not necessarily drawn to scale. Okay, with that being said, let's get into this video. Question 1, 1.1.1, we are asked to solve for x and we are given a trinomial. Okay, so because this is a trinomial, we'll open up two brackets and equate it to 0. And then what times what gives us x squared would be x times x. So the factors of 12 would be, of negative 12, would be 4 and 3. But you can see that this is negative, so one needs to be negative and one needs to be positive. But we need to ensure that the coefficient is positive 1. So we're going to give the negative to the 3 and the positive to the 4 because 4 minus 3 is positive 1. Okay, so that's going to be positive 4 minus 3. And now that we have factorized this, we can finally solve for x. So x is either equal to negative 4 or x is equal to positive 3. Since two things are multiplying and they give you 0, so it's either that the first one is equal to 0 or that the second one is equal to 0. And that is our answer. Question 1.1.2, we have to solve for x in this quadratic equation, but correct to two decimal places. So our solutions are going to be irrational, meaning we need to use the quadratic formula on this. But as you can see, this is not in its standard form because 1/2 side is not equal to 0, so the 6 needs to come over. So we will have 3x squared minus 2x minus 6 is equal to 0. Okay, so looking at this, you know that the quadratic equation, the general form is ax squared plus bx plus c. So we'll need the quadratic formula to solve for this. And then we can go ahead and substitute our values. So x equals negative and b is negative 2 plus minus the square root of b squared, which is negative 2 all squared, minus 4 times a, which is 3, and c, which is negative 6. So like that. And then this goes all over 2a, and we can see that a is 3. So 2 times 3. And then you can put this on your calculator and get your two solutions for x. And our first solution, when we substitute the negative, that gives us x equals negative 1 point. And so you see that that 9 is going to round up, adding a 1 to that 1 there. So it's going to be 12, and then you can change your sign to a plus. And if you change it to a plus, you see that we get x is equal to 1.786, but that 6 is greater than 5, so it rounds up and adds a 1 there, so you get 7, 9. And those are our solutions. Question 1.1.3, we have an equation with surds. Now, this is for 4 marks. And you can see it's for 4 marks because they've already isolated the surd for you. Okay, so let's go ahead and solve. Since the surd is already isolated, all we need to do is get rid of that surd because right now, that's what's stopping us from solving for x. So we can do that by using the inverse of square rooting, which is to square. But this is an equation, so what you do on the one side, you must do on the other side. So that will break open that. And now you have 2x plus 1 is equal to, and we have a squared binomial. So square the first term, which is x squared, then square the last term, which will be positive 1. Then we can say first term times second term, that gives us negative x. And then you multiply that by 2 since it doubles, so negative 2x. Okay, so we can take all of these over to the right-hand side since their like terms are there. So x squared minus 2x, and that comes over and also becomes a minus 2x. And then 1 and minus 1, which cancels. So all you're left with here is x squared minus 4x is equal to 0. Okay, just writing it like that. So we have a quadratic equation, but it's a binomial. And you can see that in the first and the second term, we have a common factor of x. So we take that out, and all we have in the first term, so what times x gives you x squared? It's x. And what times x gives you negative 4x? It's negative 4. is equal to 0. Again, we have this whole system where we have something multiplied by another thing gives you 0. So it's either the first number is equal to 0 or the second number is equal to 0. So if x minus 4 is equal to 0, then x is equal to 4. Okay, so we have two solutions. We still have to check whether they are valid or not, because what happens here is we squared both hand sides. Before we had done that, you see that the highest exponent on x was 1. That was the highest exponent we had, meaning there was one possible solution. But now we squared both hand sides and you ended up with a quadratic equation with two possible solutions. So we need to check whether these answers are valid or not. So we'll take the original equation and we're really just going to substitute x in here and check whether this left-hand side really is equal to the right-hand side. So 2 times 0 is 0, plus 1 is 1. The square root of 1 is 1. But here, 0 minus 1 is negative 1. Okay, so you can see that 1 and negative 1 are not equal. So 0 is not our answer. X is not equal to 0. So let's try 4. If we substituted 4 here and 4 here, you know that 4 minus 1 is 3. And here, 2 times 4 is 8, plus 1 is 9. And the square root of 9 is 3. The left-hand side really is equal to the right-hand side when x is equal to 4. So it means that x is equal to 4, but not equal to 0. And that is our answer. Question 1.1.4, we have an inequality, a quadratic inequality. So from this, you can already see it's not in standard form because it's quadratic. So the 2x needs to come over first. So we have x squared, and when the 2x comes over, it becomes negative 2x, and then minus 3 is greater than 0. Okay, we can go ahead and factorize this inequality, this quadratic expression side. So that's x times x to give you x squared, and then factors of 3. Okay, 3 is a prime number. It's negative 3 specifically. So the factors of negative 3 would be, first of all, 3 and 1, and then one of it has to be negative. But you need to ensure that you get a negative 2 in the middle. So give the negative to the bigger number. And then the 1 stays positive because negative 3 plus 1 is equal to negative 2. Okay, so that works out. So that's minus 3 and plus 1. Okay, now we can set out our critical values. Our critical values are really just like solving for x. So we're saying that x is equal to 3 or x is equal to negative 1. And now we can solve for this inequality. So to solve for this inequality, we can look at the graph it creates. Looking back at this, when the one hand side is equal to 0, you can see that this will form a parabola, but specifically a concave up parabola because the value of a here is 1. Okay, so our parabola will be concave up, and then you can draw an x-axis for it. Now, in the x-axis, on the x-axis, you will see that our critical values will lie here. So the smaller one will be here, which is the negative 1, and the bigger one is here, which is the 3. So let's look at what our inequality says. It says that this expression needs to be greater than 0. And this is when we substitute x values into here. It should give us a value greater than 0. So you see that it's referring to the output when you input values for x. The outputs are known as the y values. So they're specifically asking for where y is greater than 0. Okay, so let's just draw a y-axis just so that we can see what they're referring to. Values greater than 0 on the y-axis would lie here, not on the bottom. These ones here have values less than 0. So we're only going to look at parts of the graph with y values greater than 0. And if you map these to the graphs, you see that these are all the parts of the graphs that lie above the x-axis. Okay, so let's go ahead and highlight those. So that would be over here and over here. Okay, now we don't really need the y-axis anymore. If you map these down to the x-axis to understand where they are, the x values, because we need to answer them in terms of x. So do you see that these are values that are on the left-hand side of negative 1? So these are values that are less than negative 1. Okay, so when we're solving for x with the inequality, with a critical value of negative 1, we're saying that x is less than negative 1. And notice it's not equal to negative 1 because do you see that the inequality is just asking for where the y values will be greater than 0, not greater than or equal to 0. Okay, so that's what that looks like. And you can also see that the arrow helps you with the inequality, the direction. Okay, looking at this part, if you line these down to the x-axis, you can see that these are values that are on the right of 3. So these are values that are greater than 3, meaning the inequality here is x is greater than 3. Again, the direction helps you with the inequality. And that is our answer. Question 1.2 says solve for x and y simultaneously. So from these two equations, which can we make a variable subject? Because the whole point is they're simultaneous equations, so we need to equate them. We're really just trying to find their points of intersection. So we need to be able to substitute one equation into the other. So we need to make something the subject. Now, this equation has x sitting on its own like that. So we can actually make that the subject. So we can go ahead and call this equation 1 and call that equation 2. And then we can form equation 3 from this. So we'll leave x on the left-hand side and then we'll take that 2 over. So on the right, we just have 2y and then minus 2. And this would be equation 3. Okay, and now to finally solve for y, since we're making x the subject here, we can substitute equation 3 into equation 2. So wherever we see x, we'll substitute 2y minus 2. So we have 1 over x, so that's 1 over 2y minus 2, plus 1 over y is equal to 1. Okay, so with this equation, we can take this over. So what's going on here is we can decide to make the denominators the same, but you could also use this approach. So take 1 over y over, so you still have 1 here, and then it becomes minus 1 over y. And now you can make these two denominators the same so you can simplify them. So instead of this being 1, you could represent it in a way that its denominator is also y. And so it's like multiplying the numerator and denominator by y. So you're changing that to y over y. Okay, so what we have now is we still have this 1 over 2y, but that's going to simplify. So now you have y minus 1, and the denominators are the same, so you can write them under the common denominator of y. Okay, so now that it looks like this, because you have a fraction and a fraction, we can just cross multiply. So these multiply across and those multiply across. When you multiply these two binomials, they're really just 2y minus 2 multiplied by y minus 1, which is equal to, and those multiply and become y. And now we can distribute that. So that's going to be 2y squared minus 2y minus 2y again, and then plus 2. And we might as well take this y over. So minus y equals 0. Okay, so like terms all together, 2y squared negative 4y, that's what that becomes, minus y is negative 5y. And then we just have the positive 2 is equal to 0. Okay, so we have a trinomial here, but it's not the usual trinomial. It's the one where we have a coefficient in front of y squared or x squared that is clearly not a common factor throughout. So you can use the method you're comfortable with, but here I'll just go ahead and use a method called the cross method. So with this method, we get the factors of 2y squared. So that will be 2y multiplied by y gives you 2y squared. And then the factors of the last term, it's just 2, so it can be 2 times 1. Now, notice that this is positive, meaning the only way that you could have gotten a positive is by saying positive times positive or negative times negative. Now, how we would know which it is by looking at the middle term. If it was positive times positive, everything here should just be positive. But this is negative, so it's clearly negative times negative. Okay, so the rule is after we have cross multiplied and added, we should get the middle term. So let's see. When we multiply 2y times negative 1, we get negative 2y. And y times negative 2, we get negative 2y, which is negative 4y. And you see this does not work. Okay, so do not change your factors. You can just change the order. So we can swap these, making this 1 and 2. And let's try that again. So 2y times negative 2 is negative 4y. Y times negative 1 is negative y. And when we subtract, that gives us negative 5y. So there we go. These are our factors. So our factors are 2y minus 1 and y minus 2. Okay, so is equal to 0. And we can finally solve for y here. So 2y minus 1 equals 0. You'll take the 1 over to get positive 1 and divide both hand sides by 2 to get that y is equal to 1 over 2. Or y here, if you take the negative 2 over, is equal to 2. So we've got our solutions for y. And now we can solve for x. So you can call this equation 4. And to solve for x, we'll substitute equation 4 into the equation that has x as a subject. So that would be equation number 3. That's the one with x as a subject. So x is equal to 2y minus 2. And so this is x equals 2y, and y here first is a half minus 2. If you say 2 times a half, you get 1, and 1 minus 2 is negative 1. Or x is equal to 2y minus 2 again, so 2 times 2 minus 2. Okay, 2 times 2 is 4, minus 2 is 2. And those are our answers. X is equal to negative 1 and y is equal to 1 over 2, or x equals 2 and y equals 2. And that's our answer. Question 1.3 says, given 2 to the power of m plus 1 plus 2 to the power of m is equal to 3 to the power of n plus 2 minus 3 to the power of n, where m and n are integers. Determine the value of m plus n. Okay, so that is our main goal. Notice something that is going on with these terms. We have a repetition of 2 to the power of m here and 3 to the power of n here. So we can expand these so we can better simplify them. So that is going to be 2 to the power of m multiplied by 2 to the power of 1. Because if you multiply the same bases, you have to add the exponents. That's why we'll get back to this. Okay, and then we have 2 to the power of m is equal to, and here that will be 3 to the power of n times 3 to the power of 2 minus 3 to the power of n. Okay, so now that we have that, you see that those are clearly common factors, so we can take them out as a common factor. That's 2 to the power of m, open a bracket, and what is left in the first term? It's 2 to the power of 1, which is just 2. And then in the second term, after we've taken out that common factor, what is left? 2 to the power of m. Only if it multiplies by 1 will it get you back to 2 to the power of m. And this is equal to, and here again, 3 to the power of n is common in both terms, separated by this minus sign. So that's 3 to the power of n, and then we're left with 3 to the power of 2 in the first term, and in the second term, we would just be left with negative 1, because 3 to the power of n times negative 1 would get you back to negative 3 to the power of n. And then we can simplify these numbers. So it's 2 to the power of m multiplied by, and we can just say multiply now, by 3 is equal to 3 to the power of n multiplied by 3 squared is 9 minus 1 is 8. Okay, so at this point, you see the flow of things. They're written as 2, 3, 3. So we can rewrite this as a prime base so that the base is a prime number. So that would look like this. 2 to the power of what gives you 8? That's 2 to the power of 3. And now we can finally solve for m and n. These equations should be equal, and we need to solve for m and n that will ensure that these equations are equal. If we put them in the same order, see how that says 2 and then 3, and then if you put that as 2 and then 3, then it makes perfect sense. The only way that these two can actually be equal to each other is if the m is equal to 3 and the n is equal to the exponent on 3 here, which is an invisible 1. So therefore, m equals 3 and n equals 1. Okay, so solving their question, that was m plus n. Determine the value of m plus n. So this would be 3 plus 1, which is finally equal to 4. And that is our answer. Question 2 says, given the arithmetic series 7, 12, and 17, and this keeps going, we need to determine the value of term 91. Okay, this is just for 3 marks. So it's an arithmetic series and it's a term that we need to find. So you can use the Tn formula of an arithmetic series, which is a plus n minus 1 times d. So we are saying term 91 is equal to, and our a value, our first term, is 7. So that's 7 plus n is still 91. That's why we have tn, and that's 91 minus 1 and then times our difference. Do you see that from 7 to 12, that is plus 5, and then plus 12 to 17, that's again positive 5. So if you subtracted 17 minus 12, you get 5. The difference is just 5. And we just have to find the value of this. And that is equal to 457. And that is our answer. Question 2.1.2 says calculate the sum of 91 terms. Okay, so this is an arithmetic series. So you know that we can use these two formulas to find the sum of series, but they want the sum of 91 terms. And in the previous question, we just found the 91st term, which is currently the last term. So we can go ahead and use this formula. So Sn, S of 91 is equal to 91 over 2, and then a plus l. A is 7 because that was the first term. So 7 plus 457, 457, and we can just go ahead and find out what this is. And our answer, the sum of 91 terms, is therefore 21,112, and that is our answer. Question 2.1.3 says, calculate the value of n for which Tn is equal to 517. So they want the value of n for which Tn equals 517. You can see that if they're saying Tn, they're saying term what gives us 517. So that means we need to use the Tn formula again in this question. Now you can see in this case, they gave us a term value, Tn. So in place of the term value Tn, we'll put 517 is equal to, and then this is still 7 plus n minus 1. We don't know what n is. We're trying to look for that. And then d is still 5. So we just have to solve for n to find the term number. Okay, we can do this by taking 7 over. You see that 517 minus 7 is going to be 510 is equal to, and we can rewrite this like this. Because this is just one term, we can rewrite that 5 in front and we have n minus 1. And then we can get rid of the 5 by dividing both hand sides by 5. 510 divided by 5, that's 500 divided by 5, which is 100. 10 divided by 5, which is 2. So 102 is equal to, and those cancel, and now we have n minus 1. Then we can take this negative 1 over, and it adds to this 102. So this means that n is equal to 103. That term 103 has a value of 517, and that is our answer. Question 2.2 says, the following information is given about a quadratic number pattern. So we know it's quadratic, and they tell us that term 1 is equal to 3. Now it's best to actually put this information down. They tell us about term 1. They also give information about term 2 till term 3. So term 1 is 3. So term 2 minus term 1 is 9. Okay, so that. And then term 3 minus term 2 is 21. So term 3, whatever that is, minus term 2 gives you 21. And we need to show that term 5 is equal to 111. Okay, so we just have to complete this, and we really just need to get to term 5. So we'll get term 4 and then term 5. Okay, let's go ahead and simplify and solve really, or just counting. So to get the constant difference, because that's what's going to help us move, we're going to subtract 21 and 9. 21 minus 9 gives you 12. So this is 12. And you know that the second constant difference is constant, so it continues being 12. So to get all of these, we can actually just say that we'll still have 12 here. So 21 plus 12 gives you, meaning the third term here is going to be 33. Okay, so we'll need term 3. So we'll say term 3 plus 33 would give us term 4. So let's go ahead and fill in term 2 and 3. So here we'll say 3 plus 9 is going to give us 12. Okay, so we know term 2 now. And then to get term 3, we'll say 12 plus 21, which is also 33 like that. And so term 4 is finally 66. And then we'll continue. We know the second constant difference again will be 12. So that's 12. And so that makes the fourth term in your first difference, the arithmetic pattern, that's going to be 33 plus 12, which is 45. And then finally, the fifth term is going to be 66 plus 45, which gives you 111. So there we go. That proves that term 5 is equal to 111. And that is our answer. Question 2.2.2 says, show that the general term of the quadratic pattern is Tn equals 6n squared minus 9n plus 6. Okay, we have everything we need here. And we really just need the first three terms in the quadratic, the first difference, and the second constant difference. So we're going to make that equal to 2a. And then this is equal to 3a plus b. And this is a plus b plus c. Okay, let's go ahead and solve for a. So if 2a is equal to 12, then a is equal to 6. And so we have a. And now 3a plus b equals 9. But we know what a is. A is 6. So plus b equals 9. And 3 times 6 gives you 18. And so that's going to be b is equal to 9 minus 18. Since 9 is double of 18, that's going to be negative 9. Okay, just like they have there. And then a plus b plus c, but we already have a and b. So that's going to be a, which is 6, plus b, which is negative 9, plus c is equal to the first term there, which is 3. And this is going to be 6 minus 9 is negative 3. So we have c is equal to 3. And that negative 3 will come over and become a positive 3, which gives you 6. And so we have a, b, and c. So that concludes that Tn is therefore equal to 6n squared minus 9n plus 6. And there we go. Question 2.2.3 says, show that the pattern is increasing for all values of n where n is an element of natural numbers. So we know that natural numbers are numbers like 1, 2, 3, 4, and this keeps going till infinity as long as you're moving in natural numbers. Okay, so they're not fractional numbers, so they look like that. And we just need to prove that this pattern will be increasing for all these values. Okay, so the n are the term numbers, like term 1, term 2. And remember that terms don't really move in fractions. But okay, let's see. Show that the pattern is increasing. For us to show that the pattern is increasing, notice that this pattern, with this formula, it's going to form a parabola because it's quadratic. It has 2 as the highest exponent of the variable there. So it's going to form a parabola, and it's a concave parabola because 6 is greater than 0. So it looks like this. And what they're asking us to do is to prove that it's going to be increasing for where n is an element of natural numbers. Okay, so where is it increasing? You know that it's going to start increasing after the turning points. Here it is decreasing, it's moving down. If you read it from left, moving to the right hand side. But then this part is increasing, it's moving upwards, reading from the left to the right. Which means we can just find out where exactly that turning point is. Or we can just straight away find out how this can increase. The derivative is greater than 0. Okay, and what we mean by this is the derivative is the gradient. You're finding out where the gradient is positive. If a gradient is positive, it gives you an increasing function, a graph that moves up like that. And if a gradient is negative, it gives a decreasing function like that. So we're trying to find out where the derivative is greater than 0, where the gradient is positive. So that means where this function is increasing. Okay, so we can go ahead and derive that. That's going to be coefficient times exponent, 12, and exponent minus 1 is 1, but we don't have to write that 1. Again, same procedure here would give us negative 9, and the n falls away because of 1 minus 1 is 0. Anything to the power of 0 is 1, and that just multiplies to the negative 9. So this is now greater than 0, and we can just solve for n here. This is a linear inequality, so we don't have to overthink it. We can simply take negative 9 over. So we have 12n is greater than positive 9, and divide both hand sides by 12. Therefore, n is greater than, if you simplify that, there's a common factor of 3, so that's going to be 3 over 4. Okay, so yes, that actually does prove that. They say prove that the pattern is increasing for all values of n that are natural numbers. It's increasing when n is greater than 3 over 4. So it means you have your parabola, and we know that n will actually never be equal to 3 over 4 if it is a pattern, because patterns don't move in fractional numbers. They move in numbers like 1, 2, 3, 4. So all this means is we have the turning point at 3 over 4, and then it increases from then onwards. And we know that n cannot be fractional numbers. It's going to be numbers like 1, because 3 over 4 is less than 1. It's almost 1, but it's less than 1. So after that, we'll have 1, and then 2, and 3. And you can see that all these n values, the graph is increasing for those n values. So we can finally conclude that our graph, or our pattern Tn, is increasing for all natural values of n. So there we go. Tn, our pattern, is increasing for all natural values of n. Question 3 says, given the geometric series, and we have 3, 6, 12, and this continues to n terms, write down the general term of this series. Okay, so it is a geometric series, and the general term of a geometric series is a multiplied by r raised to the power of n minus 1. So a is your first term, and r is your constant ratio. So the first term, as we can see, is 3, so that's 3. And the ratio, we'll find that by saying term 2 divided by term 3, and that should be consistent with term 3 divided by term 2. You see that when we do that, when we divide, we get 2. So it's 3 times 2 raised to the power of n minus 1, and that is our answer. Question 3.1.2 says, calculate the value of k such that the sum of this series with this general term, starting from p equals 1, ending at k, is equal to 98,301. Okay, so it's just the sum of a series. We can go ahead and expand it. So you're going to take this 3 over 2, multiply by 2 raised to the power of p, and in place of p, we'll substitute starting at 1 and then 2 and 3. So let's just get the first 3 terms of the series. So the first term is 3. Second term is 6. And it's a series, so they're really being added. And the third term is 12. Okay, and this keeps going till the kth term. Okay, so from this, you can see that it's the same series we have here. So we'll also know that r is equal to 2. Okay, so we're still trying to find the sum of series, meaning we need to say the sum of a specific amount of terms. So we need to know what goes there. To find the number of terms, we will look at the series like this. You have to take the top minus the bottom plus 1. And the reason why is because sometimes this does not start at p equals 1. So it's safe to always use that formula. Okay, so that is the formula. But in this case, you can see that p starts at 1. So whatever this ends at is your number of terms. Again, if you said k minus 1 plus 1, you would still just get k. Okay, so we know the number of terms, it's k. And now let's go ahead and formulate our equation. So we are going to use the sum of terms. So here's our formula for that. And now we're saying the sum of k terms is equal to the a value is still the same, still 3, the first term, and then multiplied by r, which is 2, raised to the power of n, which is k, and then minus 1 all over r minus 1, which is 2 minus 1. Okay, so we already know what the sum of this series gives us. It gives us 98,301. So that is 98,301 is equal to, and we'll rewrite that, but this is 2 minus 1, which is just 1. Anything over 1 stays exactly the same, so the numerator will just stay. Okay, so when we have this, you see that to get closer to k, we can just get rid of the 3 by dividing both hand sides by 3. And let's see what we get. So we get 32,767 is equal to 2 to the power of k minus 1. Okay, so we still have k and minus 1 is just in the way. So we take it over and becomes a positive 1. So this gives us 32,768 is equal to 2 to the power of k. So at this point, you see that we have a base of 2 and then k and then a number. So the equation needs to be equal. So if you can express this as a base of 2, then we can find out exactly what k is. So let's express that as a base of 2 by rewriting it first, and then on your calculator press equal to, and then shift and the fact button. And there we go. So it means that this number can also be written as 2 to the power of 15. To make this equation equal, k should just be equal to 15. And there we go. That is the value of k. Question 3.2 says, a geometric sequence and an arithmetic sequence have the same first term. Okay, so in both sequences, we can just call the first term A, like it usually is called. So let's make columns for them. This is for our geometric sequence, and that will be for our arithmetic sequence. And we know, the only thing we know about them is that they both have a first term A, and we'll just call them A. And then they tell us that the common ratio of the geometric sequence is 1 over 3. So here, R equals 1 over 3. And here the common difference of the arithmetic sequence is 3. So D equals 3. Then they tell us that the sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence. So what that would mean is the geometric sequence has a sum to infinity. And in this arithmetic sequence, the sum of 22 terms, because they say the sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity. So it is 734 more than the sum to infinity. So if that's the sum to infinity, it is 734 more than that value. And the question is to calculate the value of the first term. So find the value of A. Okay, so this is what we have been given. In these, because they both create equations, the sum to infinity is equal to something and the sum of 22 terms is equal to something. They both create two equations, but what is common in both equations would be A and of course the value of the sum to infinity. Let's start by finding that sum to infinity. We know that the sum to infinity equals 1 over 1 minus r, and r here is 1 over 3. So the sum to infinity so long is a over 2 over 3. Okay, and if you divide that, we're saying a divided by 2 over 3. You can use the method of tip and times. So you would tip this, meaning swap the numerator and denominator, and change the division to a multiplication. So that means that the sum to infinity is equal to, numerators multiply, that's 3 over 2a. We can just call it that. Okay, so we know what the sum to infinity is here, 3 over 2a, and we know that a here is a here as well. Okay, so here we have the sum of 22 terms. So we need the sum of series formula. So that is Sn, which is 22, is equal to n over 2, but we know n is 22, so over 2. And then 2a, which is what is missing, but is common in both, so we'll still call it a, plus n minus 1, which is 22 minus 1, multiplied by our difference of 3. Okay, and then we close that. And now we are saying that the sum of 22 terms is equal to the sum to infinity and then plus 734. That is what the sum of 22 terms is. And then we'll just simplify this. So 22 divided by 2 is 11. And then here, that's just 2a. And we can now simplify. That will be 21 times 3, which gives us 63. So that's plus 63. And then let's distribute that 11 because we can't divide. So that is the sum to infinity. And we have plus 734 is equal to, and if we distribute here, we get 22 A, and we could just write A in color so that we know it's the same thing there, plus 63 times 11 is going to be, we have 630 plus another 63. So this is what we have. And you see how the sum to infinity is the subject here. We might as well make the sum to infinity the subject. So take 734 over, meaning the sum to infinity is equal to, and we have 22a, and what is 693 minus that? Just say 734 minus 693, and you know this will be negative. So that will be negative 41. So minus 41. And now we have the sum to infinity and the sum to infinity, which represent the same thing. So we're going to equate them. Sum to infinity is equal to the sum to infinity. So 3 over 2a is equal to 22a minus 41. And then we can just solve for a. So this is 22a minus 32 is equal to, and we can take that over, that's going to be positive 41. Okay, and now we can subtract. So 22a minus, this has a denominator of 2. So you can make a denominator of 2 by multiplying top and bottom by 2. So that's 44 over 2. If you say 44 minus 3, you get 41. So that's 41 over 2a is equal to 41. Okay, to solve for a, you can simply multiply both hand sides by the reciprocal of this number, which will be 2 over 41. That way, the numerator cancels and the denominator cancels. And we will do this on both hand sides. So this is going to be, remember, this is really in the numerator, that's in the denominator, so they'll cancel. So that gives you a 2 there, and these cancel completely, and that gives you an a, meaning a is finally just equal to 2. And that is our answer. That is the value of a. Question 4, sketched below, is the graph of f of x is equal to 2 to the power of x minus 4. So this is an exponential function for where x is an element of negative 2 to 4. Now notice that negative 2 is an included value here, meaning x is actually equal to negative 2. Okay, it has an actual point with the x value of negative 2, and of course it will have whatever y value comes with that. But it is going to 4 and not including 4. So this will be values that are less than 4, but not equal to 4. And of course not greater than 4, because it's cut off at this point. And then they tell us that a and b are respectively the y and x intercepts, as we can see. And the first question is to write down the equation of the asymptote of f. Okay, the equation of the asymptote, as you can see, we already have the full equation, which is in the form of a times b to the power of x minus p, of course, plus q. Q will tell you the horizontal asymptote, and it's a horizontal line, so it passes one particular y value, but it will have multiple x values. So this equation always starts with y equals. So it will be y equals whatever that value is over there, that q value, which we can see is negative 4. So this is y equals negative 4. And that is our answer. Question 4.2 says, determine the coordinates of B. We can see that B is the point where the graph intersects the x-axis. So this is an x-intercept. So at the x-intercept, we know that the y value is equal to 0. So that's what we're going to do. Take our graph, the equation, and make y equal to 0. Okay, so making y equal to 0, 0 equals 2 to the power of x minus 4. And then we can take that 4 over to make it positive. And we have 2 to the power of x. We can make the basis the same now. So that's going to be 2 to the power of 2 is equal to 2 to the power of x. And therefore, that means that the exponents are equal. So x is equal to 2. And so the coordinates of B are 2 and 0 because the y value is 0. And that is our answer. Question 4.3 says, determine the equation of k, a straight line passing through a and b in the form of k of x equals. Okay, so it passes through a and b. So we know that we have b, we just don't have a. So let's find a. A is on the y-axis. So this is the y-intercept. So to find the y-intercept, you simply make x equal to 0. Okay, so let's go ahead and do that. So that means f of 0 equals 2 to the power of 0 minus 4. And therefore, f of 0 is equal to anything to the power of 0 is 1. 1 minus 4 is negative 3. So we know the coordinates of a now. That's going to be 0 and negative 3 since the x value is 0. So what they want us to do is find the line, the equation of the line passing through A and B. So passing through these 2 points. Okay, so to find the equation of that line, we simply need the gradient. That's all we need. So let's find the gradient of that line with the gradient formula. And so the gradient of the line passing through A and B would be, we can just say top minus bottom and just follow the same order with the x values. So that's negative 3 minus 0 over 0 minus 2, which is going to give us negative 3 over negative 2. And so that just becomes positive 3 over 2. So the gradient of AB is positive 3 over 2. Now you know the equation of a straight line is y equals mx plus c. We know the gradient is 3 over 2. But what's c? C stands for your y-intercept. Notice that in these 2 points, we have a y-intercept. The y-intercept is where x is equal to 0. So here, this is our y-intercept, and that will be the value of c. Meaning the equation is just going to have c as negative 3. So remember, we need to write it in the form of k of x. So this therefore means that k of x is finally equal to 3 over 2x minus 3. And that is our answer. Question 4.4 says, calculate the vertical distance between K and F at x equals 1. Okay, so between K and F. Now, looking at it like this, it just means that we're going to have that graph connecting A and B, and then we just need to find the vertical distance, okay, at x equals 1. So let's say 1 was here. You're really just finding out what is the y value when x is equal to 1 on this straight line, and the y value when x is equal to 1 on this exponential function, and then you're subtracting their y values. Okay, so that's what we're going to do. Now from this you can see that the k will be above, definitely, because this is 2. But regardless, we would really just use their absolute values. So we can just go ahead and find it like this. So we can find the value of k, the y value of k, specifically when x is equal to 1, and then the y value of the graph of f at x equals 1 as well, so that we can find out what those y values give you when you subtract them, really just finding the distance. So k of x is equal to this, so we'll just substitute 1. And that's going to be 3 over 2 minus 3. 3 can be looked at as 6 over 2. So 3 minus 6 is negative 3. And so that's going to be negative 3 over 2. So this is equal to negative 3 over 2. And then f of 1. So that's just 2 minus 4, which is negative 2. Okay, we're really just saying the vertical distance will be found by saying k of 1 minus f of 1, and this is negative 3 over 2 minus negative 2, which of course will become a plus 2 when you distribute, and then that's going to be 2 minus 3 over 2, that's going to be a half. Okay, so the vertical distance of k and f at x equals 1 is a half. Question 4.5 says, write down the equation of g if it's given that g of x is equal to f of x plus 4. Okay, so just add 4 to f of x. So we knew that f of x was 2 to the power of x minus 4. And now g of x is simply f of x plus 4. So we're just going to add 4 to this. So 2 to the power of x minus 4 plus 4 really just gives you 2 to the power of x. But we need to remember that when writing the equation, you need to also consider the domain if there were any restrictions. So do you remember that the graph of f itself had a restriction initially? It was where x is an element of negative 2 to 4. So the graph that is shifted will also have the same domain as well. So that is still where x is an element of going from -2, the actual point -2, the x value, and ending at 4. And that is our answer. Question 4.6 says, write down the domain of the inverse of g. So here is how the relationship between the original function and the inverse works. So we'll be looking at what happens to the domain and the range. The same way the inverse function is formed by swapping the x and y value is the same way the domain and the range also switch places. Because the domain represents all the possible x values of the graph and the range all the possible y values, they would switch places. So the original function g has a specific domain. Okay, that was where x is an element of going from -2 all the way to 4. Now, this domain is going to become the range of the inverse. So that will be y is an element of -2 going to 4. And then the inverse's domain is going to become whatever the range of the original is. So clearly here, all we need to find is what exactly the range of the original is, and that will be the domain of your inverse. Okay, so the graph of g is 2 to the power of x. The range will happen based on whatever the domain is. So substitute these x values in and it will give you the y values that you can get. And then you will see how the domain will be formed through that. So g of x is equal to 2 to the power of x. And we know that the domain is where x is going from -2 to 4. Okay, now to get the range of this function, we can substitute these x values since it goes from -2 as an x value to 4. So we need to find out what the y values corresponding to that would be. So if you substituted -2, you see that that will give you 1 over 4. And if you substituted 4, that would give you 16, meaning the lowest y value would be 1 over 4 and the highest would be 16. So this means that your range is y is greater than or equal to 1 over 4. It has to be greater or equal to since its corresponding x value was greater than or equal to as well, and then less than 16. So you can also write this in intervals, meaning y is an element of, and this goes from 1 over 4 as an included y value and 16. Okay, like that. Okay, so what that looks like here is we'll just write the same thing. Y is an element of 1 over 4 to 16. And so here, the domain of the inverse is x is an element of, because it's still x values, going from 1 over 4 all the way to 16. So that is what our answer would look like. So this is our domain. Okay, so that is that question. Question 4.7 says, write down the equation of the inverse in the form of y equals. Okay, so we need the original of g first. It's this. So we might as well write it as y equals 2 to the power of x. And then to get the inverse, you first swap x and y. So this is x is equal to 2 to the power of y. Then make y the subject. But y is in the exponent. So to make an exponent the subject, we use log. So this is log and our base is 2. And then we have x. Now, this is the equation of a function. So we need to tell them what the domain is because we had a restricted domain before the translations and this inverse came about. So we already know the domain of the inverse from the previous question. So we can just tell them that. This is where x is an element of, and it goes from 1 over 4 all the way to 16. And that is our answer. Question 5 says the graphs of f, which is -1 over 2, and you can see this is a parabola, and g of x, which is a hyperbola, are drawn below. A point of intersection of f and g is B, as we can see over there, and the turning point of f. So at least we know one point on this graph of g. The graph of f has x-intercepts -3 and 0, and 5 and 0, and a y-intercept at c. And the first question is to write down the coordinates of the turning point of f. Okay, so notice that f is already put in turning point form, which is a times x minus p all squared plus q. And P and Q would stand for your turning points. So you can see that P here is 1 and Q is positive 8. So that is what the turning point B would be. B is simply 1 and 8. And that is our answer. Question 5.2 says, calculate the coordinates of C. Okay, so with C, that is the y-intercept of the parabola. Now, it's not like the parabola in standard form where that constant value is your y-intercept, because we know that that's the y value of the turning point, which is over here. As you can see, it's above C. Okay, so to find this, if it's in turning point form, you simply have to think about the fact that at the y-intercept, the x value is 0 because we go 0 and then whatever that is. So we'll just make x equal to 0 in this equation. So in place of x, we'll just substitute 0 and that's 0 over there. And let's see what we get. So f of 0 is equal to 15 over 2. Okay, so now we know that the coordinates of C, because the x value is 0 and 15 over 2. And that is our answer. Question 5.3 says, calculate the value of D. Okay, so that D value in our hyperbola. You see that in this graph, and we should just be putting down stuff that we find. We know this is 15 over 2, and we know that this point over here is just 1 and 8. So we have 1 point on this graph, and only one variable is missing. So we can substitute this point to find that variable. Okay, so this means that the g of x, the y value, is 8 equals d over 1. D divided by 1 is simply d, so d is equal to 8, and that is the value of d. Question 5.4 says, write down the range of g. Okay, so we need to find the range of our hyperbola. So with the range, do you see that this graph, it's going to have mostly every y value. Okay, so it's going to have y values all through. Here, keeps having y values all through. But it's going to get to a point where it will not have a y value. Okay, still has y values here as well. But there's one particular point it will not have a y value. You see that this moves closer and closer to this x-axis. So it's moving towards the y value of 0. And we can see that over here because this should be in the form of, it is in the form of a over x minus p, but clearly p is 0 plus q, and q is also 0. So since q is equal to 0, the horizontal asymptote is at 0, and it's a horizontal line. So it starts with y equals. Okay, but we can see that from this that it will have every y value except for the y value at 0. So it means that our range is y is an element of all real numbers, but y will not be equal to 0. And that is our answer. Question 5.5 says, for which values of x will f of x multiplied by g of x be less than or equal to 0? Okay, so what they are referring to when they say f of x and g of x is the y values of f and the y values of g. Where do we get values where we multiply them and they give us something that is negative or equal to 0? Okay, so let's look at the possible options. If the y values of f are positive and you multiply them with the y values of g, which happen to be negative, then they will give us values less than 0. And then if the y values of f are negative and the y values of g are positive, they would also give us a value less than 0. And of course, where they'll be equal to 0 is when either one of them are equal to 0 or both are. Okay, so with that being said, let's go ahead and look in our graph and see where this happens. Okay, so looking at the graphs, where the graph of f is positive, it's positive all through here. But for the same x values, the graph of g should be negative. You see that the graph of f has positive y values all through here. And one of the best ways to deal with this type of question is to use your ruler. Okay, I'll use a vertical line. So you'll move your ruler through this just to see where this happens. Do you see that over here, right? That intersection over there, they're both equal to a negative value. So it doesn't work here because negative times negative gives you a positive. Okay, not negative. And as you start moving to, if you move here, it doesn't happen anywhere there. They're both negative. But if you start moving towards the right hand side, do you see that? You get to -3. And at -3, the graph of f is equal to 0. 0 times whatever that negative is 0. So that will be an included point. If you keep going to the right, you see that that will be positive, that will be negative. That's exactly what we're looking for. We want them to be positive and negative for the same x values. So this works through here, over here, it works, and over here it works. But what happens with the hyperbola is that there is an asymptote here, okay? The asymptote, the vertical asymptote is at x equals 0. We saw that because the graph of g did not have a p-value, meaning it's 0. Okay, so with this one, it starts at -3 specifically, so, and gets to 0. And it's equal to -3 as well, meaning there we'll say that x is greater than or equal to -3, but less than 0. Okay, it does not include 0 since that is an asymptote. And then if we look to this side, where does that happen? Well, it's positive all through here. The graph of g and f are both positive, so we're not looking for that. We don't want where they both have positive y values. One must be positive, one must be negative. So the best place to check for them would be once one of them hits the x-axis, because at the x-axis the y value is 0. So that means that after this, look at this, the graph of f becomes negative, and for the same x values, the graph of g is positive all through. So if you take those positive y values and multiply it for those same x values with the negative y values here, they will give you a negative answer. Okay, so here it also works where x is equal to 5 and values that are greater than 5, because it keeps working all through here as well. So greater than or equal to 5, and those will be our solutions. So we'll say that x is greater than or equal to -3, but less than 0, or x is greater than or equal to 5. And you can leave your answer like this or write it as intervals, which would be where x is an element of, and it's going to go from -3 being an included x value till 0, and then round bracket here because it's not included, and then union where we're going from 5, and you see its value is greater than 5, so to positive infinity. So this will be from included value of 5 to positive infinity. So that's another way we could write that. And that is our answer. Question 5.6 says, calculate the values of k so that h of x is equal to -2x plus k will not intersect the graph of g. Okay, so we're just going to manipulate this equation. Okay, so we're looking at h of x and g of x, and they need to not intersect. So it's like trying to ensure that they do not intersect, so they're not equal, but we'll make them intersect first and then manipulate them so that they should not intersect. Okay, so h of x is -2x plus k, and we know that g of x is our hyperbola, and only d was missing here, so we'll just put d as 8. So that is just 8 over x. Okay, let's simplify. We can cross multiply, so this multiplies with the x, meaning x times -2 is -2x squared, x times k is positive kx, and then we'll just be left with 8 when you multiply on this side. So you might as well take the 8 over, so -8 is equal to 0. Okay, so this is what we have, and we can just manipulate the discriminant to ensure that these do not intersect. In other words, to ensure that they do not have any real roots, we can make the discriminant less than 0, because the discriminant is that part of the quadratic formula that says the square root of b squared minus 4ac. If this is negative, you get a non-real answer. Okay, so that's what we're doing. So we're going to make the discriminant less than 0. The discriminant is b squared minus 4ac, and we're going to make that less than 0. B is k, so that's k squared. We just say k is squared minus 4 times a, which is -2, times c, which is -8, must be less than 0. So we're just solving for k in this clearly quadratic equation. Okay, so k squared, and 4 times 2 is 8. Okay, that will be positive. Times negative 8 is negative 64, is less than 0. Okay, so we can factorize this using difference of two squares. So less than 0, k times k gives you k squared. And then 64, the square root of 64 is 8. So that's going to be plus 8 and minus 8. So from this, you can see that our critical values are k equals negative 8 or k equals 8. Okay, and so now we're going to solve for k. So this is an inequality, and we can see that we have k squared, and the coefficient of k squared is a positive 1. So this is a concave up parabola, and we're solving for k here. The first k value is negative 8 and then positive 8. And we need to find where this function is less than 0. Where does it have y values less than 0? Okay, where it has y values greater than 0 will be above here. So that will be every part of the graph with y values greater than 0. But we need the ones that are less than 0. So that's below the x-axis. So we'll highlight every part of the graph below the x-axis, which is all through here. And if you map these up to the x-axis, do you see the values that they give you? There are all these values in between here, and you have to be able to describe them relative to their critical values. So with negative 8, you see that it's values that are greater than negative 8. And with 8, it's values that are less than 8. So you can see this ranges from negative 8 to 8. This is where k is greater than negative 8, but less than 8. And that will be our answer. If k is greater than negative 8 but less than 8, then we will have non-real solutions, meaning those graphs will not intersect. You can, of course, write this in intervals, which would be like this. K is an element of, and it's going to go from not square bracket because it's not included. So negative 8 all the way to positive 8. And that will be our answer. You can either write it like that or like this. Question 5.7 says, H is a tangent to G. Okay, so H, the graph we just worked on, is a tangent to G at R, at this point R, a point in the first quadrant. Then they tell us to calculate T such that this equation, this line, y or graph, y equals f of x, okay, so it's a parabola, intersects with G at R. So H is a tangent to G at R, a point in the first quadrant. Calculate T such that y equals f of x plus T intersects G at R. So at the end of the day, they are all intersecting at R. Okay, so let's just see a visual example of this. We don't really need all the graphs really, but with this, we can just look at it like this. You see, there's a graph H, and it is a tangent to G. For a graph to be a tangent, it has to be a straight line, okay? Okay, we already know what H looks like. So H is a tangent to the graph G, which is a hyperbola that we know looked like this, and the other one was like that. But it intersects in the first quadrant, so we won't even have to look at the other wing. Okay, so everything is happening here. We have a tangent, and that tangent is H, and H is intersecting with the graph of G. So it's like that, and that's H, and this is G, and then it's intersecting at this point that they said is R. Okay, so we need to find T, calculate T such that y equals f of x plus T intersects at R. So the main goal here is we need to find out what R is. If we find the coordinates of R, we can find what T is if this intersects with R, because this graph intersecting with R simply just means that it passes R, meaning you can take the coordinates of R, substitute it into this equation, and it will help you to solve for T. So the main goal is find R, the coordinates of R. Okay, what have they given us to find the coordinates of R? They have told us that H is a tangent to G. What do we know about tangents and graphs. At that point of intersection where that is a tangent to this graph, they will have the exact same gradient, meaning the gradient of g would be exactly the same as the gradient of h. So we can work with this. We know what the graph of g of x looks like. It's the hyperbola that is 8 over x. And the graph of h is what we just found while we were working with the graph of h, which is negative 2x plus k. And that plus k doesn't matter because we just need the gradient. That's all we need there. This will help us to find out where they intersect. What is going on at that point of tangency? We need to find out what those x values are. So h of x, we're not really bothered about what it is. We just want to find out the gradient. Now you see that to find the gradient of this, in other words, to derive this, you still need to prepare it. The x is in the denominator, it should move up to the numerator. Okay, so now they'll be ready to derive. So if you say g prime of x is finally equal to h prime of x, then we're really just saying we're going to derive that. If you derive that, you're saying coefficient times exponent, which is negative 8, and then x, and then exponent minus 1, which is negative 2, is equal to the derivative of h, the gradient, is really negative 2. Okay, that's the gradient. It's a straight line, a decreasing function with the gradient being equal to negative 2. Okay, so that's negative 2. So we just need to solve for x here. That will be the x value of r, that point of intersection. Okay, so this is going to be divide both hand sides by negative 8 to solve. Okay, so x to the power of negative 2 equals, and that will be positive 1 over 4. And then you can just move that to the denominator since the exponent is negative. So what we'll have here is 1 over x squared equals 1 over 4. And so this would mean that you could cross multiply, but we can also just see that this means that x squared is equal to 4. Okay, so if you square root both hand sides, then we get a positive and negative solution. So x is either equal to positive or negative 2. But remember what they told us. They told us that this intersection happens in the first quadrant and the x value would be positive in the first quadrant. So x is clearly equal to positive 2. Okay, now that we know the x value, we can simply find the y value. Remember, it lies on g and h. Now, even though we don't have k here, we have g. We have the full equation of g. So let's substitute that 2 in here and we'll find its y value. Okay, so that's g of 2, which is going to be 8 over 2, which is equal to 4. Okay, so now we know what r is. That point of intersection is at 2 and 4. And all we need to do is calculate t such that this y equals f of x plus t intersects. If this is 2 and 4, for this graph to intersect this, we just need to substitute this into here because we are saying this is a point on this graph y equals f of x plus t. Okay, so this is the y value is 4 is equal to the x value is 2. So we're going to say f of 2 plus t. But now we need to find out what f of 2 is because this is a different graph. So that's the parabola. Let's just see. If we substitute 2 here, what happens? We get 15 over 2. So f of 2 is equal to 15 over 2. And now we can continue this. So this means that 4 is equal to 15 over 2 in place of f of 2 plus t. And then just solve for t. So t is equal to, and since they're both going to be, this is already over 2, that becomes a minus 15 over 2. And you still have the 4 here. So you might as well put that as a denominator of 2. So it's going to be 8 over 2 because 8 divided by 2 is still 4. 8 minus 15 is negative 7. So negative 7 over 2 is equal to t. There we go. So t is just finally equal to negative 7 over 2. That's what t needs to be for f to intersect at r. And that is our answer. Question 6 says 6.1. Patrick deposited an amount of 18,500 into an account earning R% interest per annum compounded quarterly. Okay, this is the amount deposited. And they tell us that after 6 months, his balance was 19,319.48 cents. And we need to calculate the value of R. So you can see from this, one single amount is being deposited and then it grows. So this is a case of compound interest growth. Okay, so the formula of compound interest growth looks like this. And now we can start looking for the values. So A is the end amount that we get. We know that the account ends up with 19,319.48 cents. And then the amount that was deposited was 18,500. So that's your starting amount. So 18,500 goes in place of P. Then we have 1 plus our interest. Now that's what we're looking for. But remember that this is compounded monthly. So we need to account for that. So that's going to be, we can say R over 12, okay, because whatever that rate is going to be divided by 12 since it needs to earn interest every month. And then raised to the power of whatever the time period is. They tell us 6 months. Notice that they don't put it in years. They don't say years. So it's already in months. So we can just leave it as 6. You don't have to multiply by anything because it's already in months. Okay, so the main goal here is just to solve for R. Okay, so solving for R. To get closer to R, we can get rid of this 18,500 on both hand sides. And when we do that, we get 1 point. Now, we can leave this as decimals, but just do not round off yet. So it's equal to, and then we're left with on this side, 1 plus R over 12 raised to the power of 6. Okay, getting closer to the R. The next thing that will be stopping us from getting closer to the R would be the 6. So we need to get rid of that to the power of 6. And we can do that by finding the 6th root. So we'll have to do that on both hand sides of this equation. And this leaves us with 1 plus R over 12. And then on this side, we can find the 6th root. Now, on your calculator, it will actually work fine if you say that. I'm just going to have to make adjustments here. So we are going to find the 6th root of whatever the answer to this is. So we're going to say 6th root of ants, which we can put as decimals. So this is 1.007 and it keeps going. Then we can go ahead and take this 1 over. So when you take it over, it's going to be minus 1, which gives you a 0.007, and that keeps going. And just make sure that you do that on your calculator as well, so that is applied. And now we have R over 12, and we can get rid of the denominator of 12 by multiplying both hand sides by 12. So lastly, we take our answer and we say multiply by 12. And this is what we get. R is finally equal to 0.087 and 0, and this keeps going. But then it needs to be a rate, like they said, R%. So you're going to multiply that by 100 so that it is written as a percentage. So that R is finally equal to 8 points, and that's just going to be 8.7%, and that is our answer. Question 6.1.2 says, calculate the effective interest rate. Okay, so do you see that in the previous question? This interest was compounded monthly. The effective interest rate is going to be the yearly interest rate, and there's a formula for that. It is 1 plus I effective, so that's the effective interest rate, is equal to 1 plus I nominal, the nominal interest rate over n, raised to the power of n. So here is where you're going to put the interest rate that was compounded, let's say monthly or quarterly. And we know that the interest rate that we had was compounded monthly. So we're trying to find the effective interest rate, the yearly interest rate. So the nominal interest rate is what the bank quotes, right? What we had here, the compounded monthly. And then the effective interest is the actual interest that gets accumulated in that year. So 1 is what they quote you, 1 is what actually gets applied. And it's really because with nominal, we're not taking into account that interest adds on interest. So the effective would usually be more than this nominal. Okay, so this is what we have, and we know the nominal already. We know that it is 8.7. So we're going to say 1 plus I effective because this is what we are looking for. Well, we'll take the 1 over. So it's equal to 1 plus, and we're saying 0.0, and we'll say 87 over, now that was compounded monthly, and then raised to the power of 12 because it's compounded monthly. We want to see what that 12-month interest actually is going to be in a year. Okay, so we're taking the 1 over and it becomes minus 1. Okay, so this will give us our answer in decimal, and then we'll just multiply by 100. And this is our answer. It is 0.09055, right? And then we will multiply this by 100 so that we can get the actual rate. So I effective is equal to, and take that and multiply by 100. So that is 9.0. And you see the second 5 will round up, adding a 1 to that 5. So 0.06%. And that is our answer. So yes, they quoted 8.7% per month, but in a year, this is actually 9.06%. Okay, moving on to the next question. Question 6.2 says, Kuda bought a laptop for 10,000 Rand on the 31st of January 2019. He will replace it with a new one in 5 years' time on the 31st of January 2024. So we know that that will be in 5 years' time. 6.2.1 says the value of the old laptop depreciates annually at a rate of 20%. So it depreciates, okay, per annum according to straight line method. After how many years will the laptop have a value of 0 Rand? Okay, so we can see that this is depreciation going on. So the formula is A is equal to P and then 1 minus I times N because it's straight line, so it's a linear. So the P value, this is the starting point. We know that Kuda starts off with a laptop that is 10,000. This is where he starts. And we want to find out what happens when the laptop ends up being this price or this value. So A is 0, that's the ending point, and the starting is 10,000. And then we are saying 1 minus, and our interest is 20%. So we can say 0.2 or 20, that's fine. Multiply by, now remember that we need to find out how many years will it take the laptop to reach a value of 0. So N is unknown. We don't know how many years it will take for it to reach this. Okay, let's go ahead. So we can start off by dividing both hand sides by 10,000. But you know, if you say 0 divided by 10,000, you simply just get 0. And then we'll have 1 minus 0.2 and N. Okay, we can just take this over since it is negative. So it becomes positive 0.2 N. And then we have the 1 on this side. Divide both hand sides by 0.2, and that's going to tell us what N is. So N will be equal to, that will be 5, since it takes 5 sets of 0.2s to get a 1. So 5 years. That's how long it will take for this laptop to get to a value of 0. Okay, moving on to the next question. Question 6.2.2 says, Kuda will buy a laptop that costs 20,000. In order to cover the cost price, he made his first monthly deposit into a savings account on the 28th of February 2019. Okay, so we need to be putting these down. So we know that on the 28th of February 2019, then this is where the first deposit happens. And this goes on, and they say he will make his 60th monthly deposit on 31st January 2024. So this is on 31 Jan 2024. So that will be exactly 5 years of depositing because the 60th one is here. Okay, and the first one is here. The savings account pays interest at 8.7% per annum compounded monthly. Calculate Kuda's monthly deposit into this account. Okay, so he's going to keep making monthly deposits so that he can reach an amount of 20,000 at the end of these 5 years. So clearly Kuda is saving money So when we're working with savings and someone keeps periodically depositing money, so every month or every quarter, then this is future value. So here's the future value formula. So the future value, the amount that he wants to have is 20,000. 20,000 rand. And then the amount that he keeps depositing X, we don't know that and we're trying to find that. And then we also know the interest, so 1 plus, and we know it's compounded monthly. So it is 0.087, and this goes over 12 because it's compounded monthly, and then raised to the power of 60, okay, because 60 deposits, and then minus 1 all over the interest again. Again, so 0.087 over 12. And we just need to get to the x. So with x, it's quite simple because you're really looking at it like this. You see all of these? They're going to multiply and divide and they'll just give you one single number. So you're going to take this single number and just divide both hand sides by it. So you're really saying 20,000 divided by all of this, and that will give you x. So like that. And finally, x would simply be equal to this. So this is 267 Rand and 26 cents. That's how much Kuda needs to save monthly. Okay, so that's how much he will deposit every month. Moving on to the next question. Question 6.3 says, Tino wins a jackpot of 1,600,000 Rand. He invests all his winnings into a fund that earns interest of 11.2% per annum compounded monthly. Okay, so wins this amount. Now he withdraws 20,000 from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment, which is normal. How many withdrawals of 20,000 will Tino be able to make from his fund? So this situation is a case where Tino is giving the bank money because he's investing this money. So it's not that Tino is borrowing money from the bank, but rather he's giving the bank money. And the bank needs to give Tino back. So he gives them this amount, kind of like a loan. And then the bank needs to give him back 20,000 every month. And we just need to find out how long this will go on for. Okay, how much 20,000 rands can he withdraw from this bank? So this is a case of present value, but it's just not Tino borrowing money from the bank. Rather, it's kind of like the bank borrowing money from Tino. So we're going to need the present value formula. And here are the amounts. The present value is always the loan amount. How much is being given to the bank? It's 1,600,000. That's how much basically Tino is loaning to the bank. And X will be the monthly payments, okay? Because Tino is getting money from the bank, 20,000 Rand each month, the bank has to pay Tino 20,000 every month, meaning that is X. That is the repayment. Okay, so this is the amount that the bank is paying Tino back every month for his investment. And then again, 1 minus 1 plus, and the interest is 11.2. So that's going to be 0.112. And it's compounded monthly, so over 12. And then raised to the power of negative n. Negative n would be how many more payments still need to be made. Now, we do not know that because that's what we're looking for. So we'll leave that as negative n. And then, of course, over the interest, which is already here. Okay, so let's go ahead. We're trying to find n. So how do we get closer to that n? Okay, so if we want to avoid working with decimals, what we could do is go ahead and take this to the numerator. In other words, we're going to multiply both hand sides by 0.112 over 12, and it's going to end up sitting right next to the 1.6 million. So it's going to be like that, and then everything else here will come here. So there we go, we have this. And now the next thing stopping us from getting to the negative n would be the 20,000. So we can divide both hand sides by 20,000. So the 20,000 will be the denominator here. Okay, and all we'll have is everything here excluding the 20,000. So there we go. And now from this, you see that we actually have the base be negative. So here's our exponent. this is actually negative because it has a negative in front of it. So why don't we just take it over to make it positive? So if we take that over, it becomes positive, and we still have the 1 here. So 1 minus all of this. So now to simplify this, we can go ahead and find out what this is as a fraction when we add them together. Okay, which is 757 over 750, and it's raised to the power of negative n still. Then we have is equal to, and then let's find out what all of that will give us. And that gives us 19 over 75. Okay, and now we can finally solve for negative n. So we'll say negative n is equal to, and since we are solving for an exponent, we're going to use log. So log, and our base is this, so 757 over 750, and our answer was 19 over 75. And let's go ahead and find out what this is. Okay, so negative n is equal to negative 147.7978, and that keeps going. And you can either multiply or divide both hand sides by negative 1 to just make that positive. So we're saying that n is equal to 147.7978, and this keeps going. So here's the thing about their question. They specifically said, how many withdrawals of 20,000 will Tino be able to make? So the 147, that would be full withdrawals of 20,000. Those are full withdrawals of 20,000 Rand that Tino would make. This part is not a complete 20,000 yet. And you can even confirm this on your calculator by using the present value formula. If you take this and in place of n, just substitute that amount, right, as a decimal, it will give you an amount that is less than 20,000. So to answer their question, how many withdrawals of 20,000 can be made? It would be exactly 147 withdrawals of 20,000 Rand. And that is our answer. Question 7.1 says, determine f prime of x from first principles if f of x is equal to negative 4x squared. So from the formula, the derivative using first principles, you know that you're going to have to find the f of x plus h. So let's go ahead and expand that already. Wherever you see x, replace it with x plus h. So this is negative 4 multiplied by x plus h, and then all squared. So when we simplify this, it's negative 4. And here, distribute this. So it's going to be the first term squared, x squared, last term squared, plus h squared, and then first times second term, which is xh, and then times 2, which is positive 2xh. And then we distribute the negative 4. So that's negative 4x squared minus 8xh minus 4h squared. Okay, and let's go ahead and put down our formula. Okay, and we can go ahead and substitute. So the limit as h approaches 0, and f of x plus h is all of this. And we're saying minus, and we're subtracting by negative 4x squared. So that's going to be minus 4x squared. Okay, and then all over h. So those will distribute and just become a positive. So we have the exact same thing here, just it'll change to a plus. Okay, and then whatever we were subtracting by will cancel here. So these two cancel, and then all we are left with is the limit as h approaches 0, and we have negative 8xh minus 4h squared all over h. Okay, and now we can solve the problem that we had, which was that the h was in the denominator. So we're going to take h out as a common factor, and we have negative 8x minus 4h. And now finally that h cancels there, and it's no longer a problem. We will not have an undefined expression. So this is going to be, you can go ahead and substitute at this point. So f prime of x is equal to, and we have negative 8x minus 4, and in place of h, we substitute 0. So this means that f prime of x is finally equal to negative 8x, and that is our answer. The next question, 7.2.1, we have to determine f prime of x if f of x is equal to this. So as you can see, this is perfectly fine. It's ready to be derived using the rules of differentiation. So we can go ahead and start by saying f prime of x equals coefficient times exponent will give us 6x, and we have exponent minus 1, which is 2. And then the same thing here, coefficient times the exponent of 1, which is 3, and x will fall away because we have an exponent of 1, and we'll say minus 1, which becomes 0. X to the power of 0 is 1, and negative 3 times 1 stays negative 3, and this is our answer. Okay, the next question, we have to derive this. So check, is there anything that needs to be simplified further? Yes, okay, so the surd, we shouldn't have surds. So let's go ahead and clear that up. So since we are not deriving yet, we'll still say dx, and that's going to be, we have 7, and then we can rewrite the surd like this. So we're saying the inside exponent over the outside exponent. So that is x to the power of 2 over 3. And then we have plus 2x raised to the power of negative 5. And now we are ready to derive. So this is equal to coefficient times exponent, and that's going to give you 14 over 3x. And then we're saying exponent minus 1. So that's 2 over 3 minus 1, which you can look at as 3 over 3, which is going to be negative 1 over 3. And then coefficient times exponent is negative 10x. And exponent minus 1 is negative 6. Okay, now to check whether we're done, we just have to look at the mark allocation. It is 3 marks. You get a mark for writing it in a format that you can derive there. And then you get a mark for deriving each term. So there's the mark, and that is the mark. So there we go. We are done with that question. Moving on to the next question. Question 7.3 says, for which values of x will the tangent to f of x equals this, okay, have a positive gradient? So you can see that this is a concave down parabola, right? And if they're referring to a tangent, right, that has a positive gradient, so you have this increasing function because it has a positive gradient. So when you want to find out where this graph, the tangent to this graph, will have a positive gradient, notice that the gradient of the curve and the tangent at this point would be exactly the same. So what they're really asking for is, where will this curve have this positive gradient, the same gradient as the tangent? In other words, where will this curve have a positive gradient? To find the gradient of this function, we would derive it. So we'll find f prime of x. And to ensure that this gradient is positive, we will set it to be greater than 0. Okay, so we're making it greater than 0 because we want it to be positive. So let's go ahead and derive that. That's going to be negative 6x squared, and then plus 8 is greater than 0. And we simply have to solve for x in this inequality. Okay, so straight away, do you see that with the first and the second term, we have a common factor of, we can just say negative 2. So let's go ahead and divide both hand sides of this inequality by negative 2. And so that leaves us with, that is now going to be positive 3x squared, and that is negative 4. But we just divided by a negative, so it's going to cause our sign to change direction. So now it looks like that. It's less than 0. Okay, let's go ahead and solve. It is quadratic. Yes, this is not a square number, but we can still treat it as a square number. So we can use difference of two squares to factorize this. So open up two brackets, it's still less than 0, and find the square root of this. Square root of 3 would be square root 3. Square root of x squared is x, and then again square root 3, and then x. And then the square root of 4 is 2. So 2 and 2, and then say plus and minus. And now we can find our critical values. So our critical values would be, it's like equating that to 0. So square root of 3x plus 2 equals 0. And you're going to take the 2 over, which gives you a negative 2. And then divide both hand sides by square root 3, which is now x over root 3. With this, because the sign was just different, that would be positive 2 over root 3. So those would be our two critical values. And let's go ahead and solve for this inequality using a graph. So we can draw an x-axis and our graph. The graph we can look at can be this. That's fine because that was the simplified one we had. And then we're going to draw our parabola. which we can see is a concave up parabola since the value of a, okay, coefficient of x squared is positive. And our critical values are negative 2 over root 3 and positive 2 over root 3. So do you see that the inequality says less than 0? So these refer to the y values. They are the result of substituting x values in here. We need to ensure that this is going to be less than 0. So looking at the y-axis, those y values, the values less than 0 are over here. Okay, and you can see that if you map these to the graph, these are these parts of the graph. They are parts of the graph that lie below the x-axis. So we're not going to use anything above the x-axis, but just everything below. So if you highlight that, that's all through here. And now we can line them up to the x-axis so we can understand where these points are. So relative to negative 2 over square root 3, these are values that are moving to the right of it. So these are values that are greater than negative 2 over square root 3. But over here, do you see that these are values that lie on the left-hand side of 2 over square root 3. So they are greater than negative 2 over root 3, but less than 2 over root 3. So our answer finally is x is just greater than negative 2 over root 3, but less than 2 over root 3. And that is our answer. Question 8 says, given f of x is equal to, and we have a cubic function, and it's also been factorized. Okay, so 8.1, determine the coordinates of the turning point of f. So this is a cubic function with the value of a being negative. So it's going to look like this. So kind of like a backwards n, just more curved. And at the turning points, we know that this is where the gradients are neither increasing nor decreasing. They're stationary. So the gradients are equal to 0. So we'll go ahead and find the gradient of this function by deriving it. So that's f prime of x is equal to, and coefficient times exponent, negative 3x, exponent minus 1 is 2. Then that is going to be plus 12x and minus 9 using the same rule. Now this represents the gradient, the general gradient of this function. And we're going to make the gradient equal to 0 so we can find those specific turning points. So it's negative 3x squared. Again, everything just repeats. Okay, so you can see that we have a common factor of negative 3 all through. So we can just go ahead and divide both hand sides by negative 3. Then we have, and we can just write this over here, that's fine. So that's going to be positive x squared. That's going to be negative 4x, and positive 3 is equal to 0. Okay, factorize. So open up two brackets is equal to 0. X multiplied by x is what gives you x squared. And then we need factors of 3. 3 is the prime number, so it's just going to be 3 and 1. And you can see that the middle is negative, so both factors should be negative. Negative 3 times negative 1 give you positive 3, but negative 3 minus 1 give you negative 4. Okay, so this means that x is either equal to 3 or x is equal to positive 1. And those would be the x values of our turning point. We would still need to find the y values. So to find the y values, substitute it into f of x, which stands for y. So we can go ahead and substitute. So this is f of 3 is equal to, and we say negative 3 all cubed plus 6 times 3 all squared minus 9 times 3 plus 4. And you can just substitute this, input this into your calculator, which gives us 4. And then we can just find, well, with the other one, we don't actually have to substitute. Here's the thing. Do you see what the factorized version looks like? You have one that says x minus 1 all squared. This means this is the type of cubic function where one of them is going to lie on the x-axis, one of those turning points. So the one that lies on the x-axis is the one that gets the squared. So we already know that the y value of that would be 0 because that's the x-intercept. So that's f of 1 equals 0. Okay, so that means our turning points are simply 3 and 4 and 1 and 0. And there we go. That is our answer. Question 8.2 says, draw a sketch of the graph of f Clearly label all intercepts with the axes and any turning points. Okay, so we can just follow some steps here to draw this graph. So first, let's consider the shape of the graph. Now, the shape of this graph, you can see from here, if it has a negative in front of the ax cubed, okay, that a value, then it's going to look like a backwards n, okay, that is just more curved. So we already know the shape. We know that it looks something like that, okay? Then the second thing we can consider would be our turning points. Now we already know those. It's 3 and 4 and 1 and 0, okay? And then thirdly, we can consider what our x-intercepts are, or our y-intercepts as well. So the intercepts, okay? So we can start off with the y-intercept. It's usually much more simple to find. And the y-intercept would be a result of substituting 0 in place of x. So it's always going to be the constant, whatever it does not have x. And that is positive 4. So it means that your y-intercept as a coordinate would be 0 and positive 4, because that's where the x value is 0. And then the x-intercept, since they've already factorized this for us and we know one of it, it's 1 and 0. And then the other one we can find here because they factorized it for us. So that is this over here. You see, if you equated these to 0 as they are, x minus 1 all squared and then negative x plus 4 is equal to 0, then this is equal to 0 and it eventually just gives you x equals 1. And then this, it's just take the negative x over. So you just have x equals positive 4. Okay, so there we go. We could already see it from there. X is clearly just equal to 4. Okay, that's a bracket. And 4 and 0. Okay, so that's really all we need. They didn't really ask for points of inflection. They only asked for intercepts with the axes and turning points. So now sketching our graph, we already know the shape. The best thing to do is to sketch the graph down with the shape. So we know that our graph will look like that. And then we can add our x-intercept. Now we know that this point 1 and 0, because it is a turning point and also an x-intercept, it's going to lie on the x-axis. So it is the smaller turning point, as we can see, because the x value is 1. So that will be it. And then this is the one that is 3 and 4. So you can just ensure that you draw your graph in a way that okay, is where the x-axis is going to be drawn. The x-axis needs to intersect with that point. So I'm just going to pull this a little down like that, and we would just draw a line. This is to avoid numbers and stuff because we don't really need them. So that's our x-axis. And now where to place our y-axis. Our y-axis depends on where our y-intercept is. We know that the y-intercept is 0 and 4. So that is a positive y-intercept. So when you're drawing your line down, you can't draw it here because it's not going to intersect there. And you know that this is 1, so you actually have to understand where these x values are. And this is 3 and 4. Okay, so 0, that y-axis, must be this side. So it's going to be like that. And then we can just say that's where it intersects 4. Okay, I just moved it more to the left to make it look more realistic. So it's going to intersect over there. Okay, so the points we have down, we have the y-intercept, we have this x-intercept, we have the turning point, and this point is 4 and 0, so the other x-intercept, which appears over here. So that's 4 and 0, and you can just say 4. So there we go. These are all our points, and that is our graph of f. Moving on to the next question. Question 8.3 says, use the graph to determine the value or values of k for which the graph, the function that we have, is equal to k will have 3 real and unequal roots. Okay, so we need to ensure that it has 3 roots. But here's something that happens that's actually really interesting and we need to take into account. Do you see that it is equal to k? So what will happen with this expression is when you want to find the roots, okay, one hand side needs to be equal to 0. So you need to take the k over. So this k is already going to become negative, which may or may not help us depending on what the graph looks like. Okay, so here is f, and then that k comes over and becomes a minus k is equal to 0. Okay, so here is what happens in our graph. Because we have minus k, we just have to see what should this graph do so that it has 3 roots, okay, 3 x-intercepts. Currently, it has 2 x-intercepts. So which direction should we move it to ensure that it has 3 x-intercepts? Okay, here is a duplicate. You see that if you move it up, that does not solve our problem because it will only ever have 1 x-intercept. This no longer intersects the x-axis. So you're going to have to move it down. When you move it down, you see 3 x-intercepts. Keeps having 3 x-intercepts until you move it to the point where the local maximum sits on the x-axis. And then what happens there is now you have 2 x-intercepts. So the good thing we know now is you just have to push it down anything more than 0 units. Okay, if you push it down 1 unit, it has 3 x-intercepts, 2 units, 3 x-intercepts. So push it down anything more than 0 units, but no more than what? Since at first, the local maximum was at 3 and 4, meaning the y value was 4. And now we need to push it until it gets here, and we shouldn't push it beyond this, because if you go beyond this, then you see that we just have the same problem again. 1 x-intercept will keep happening. So we need to move it to this point. So it used to be at 4, and we need to push it down until that y value is at 0, because this will be 3 and 0. Okay, so we need to move it anything more than 0 units, but no more than 4 units down. Okay, so take into account it's moving down, but our k here is already negative, which already accounts for a downward shift. So all we need to just tell them is what k will be. Tell them that k just needs to be anything greater than 0, but less than 4 units. And if you had to apply that there, they would shift the graph in a way that will ensure that it's just going to have 3 x-intercepts, okay? And this will be our answer to this question. Question 8.4 says, the line g of x equals ax plus b is a tangent to f at the point of inflection of f. Determine the equation of g. Okay, this line is a tangent to f at the point of inflection. So we already know the point where it's going to be a tangent. That already helps us a lot, because it is this same cubic function of f, and the line we are referring to is a tangent at that point of inflection. So since this is a straight line, we just need to find that gradient, which is currently a, and the y-intercept. And for you to do that, all you need is to find the gradient first, and then 1 point you need to substitute in here to find that y-intercept, and then that will give you the full equation. So clearly we need to find that point of inflection. Okay, so this is our equation of f. How do we find the point of inflection when we have this equation? We find the point of inflection by finding the second derivative of the graph and then set it equal to 0. So first, when we derive, which we already had, but okay, negative 3x squared plus 12x minus 9, and then we'll find the second derivative and set it equal to 0, of course. So when you derive here, that's going to be negative 6x and then plus 12, and the x will fall away, is equal to 0. And we have negative 6x is equal to negative 12. That's perfectly fine because we'll just divide both hand sides by negative 6. Therefore, x is equal to positive 2. Okay, so we already know what this x value is. We might as well find the y value since we need to know what exactly that point is. So we can find the y value by substituting x into the original function. So that will be f of 2. Okay, and that is 2. So f of 2 is equal to 2. So we know what that point is. That point of inflection is 2 and 2. Great. Now that we have that, remember that the main goal is to find g of x. So we need the gradient of g. Well, we know that it's a tangent at this point. So if we can find the gradient of this curve at this particular point, we would know the gradient of the tangent, because the gradient of the tangent is constant. It's not going to change like the way the curve's gradient changes. since it is a straight line. Okay, so let's go ahead and find the gradient at that point. We know the gradient of this curve. The gradient of this curve is this. Okay, the first derivative of our function. That's how to find the gradient. But we need the gradient at that particular point of inflection. So we'll find the gradient at the point where x is equal to 2, okay, because that's the x value. So we'll substitute f prime of 2 is equal to negative 3 times 2 all squared plus 12 times 2 minus 9. And that gradient is 3. So f of 2 is equal to 3. So now we know what the gradient is. So in our graph g of x, we'll just rewrite that. G of x is equal to ax plus b. That a value, the gradient, which is usually in the form of mx plus c, that is just 3. So we're saying g of x is equal to 3x plus b. And now to solve for b, we can just substitute a point on this straight line, which is the only point we have, the point of inflection, which is 2 and 2. So we're saying 2 as the y value is equal to 3, and then in place of x, 2 as the x value plus b. So we can see that that gives us 6, and if you take it over, 2 minus 6 is negative 4. So b is simply equal to negative 4. And so the equation of g is 3x minus 4. And that is our answer. That is the equation of g. Okay, the last question for question 8 says, calculate the value of theta, the acute angle formed between G and the x-axis in the first quadrant. So as you can see, G has a positive gradient, okay, 3, so it's greater than 0. So it is an increasing function. It's a straight line that increases, reading it from left to right. And we know the equation of G. So we know what G is and we know what its gradient is, which is really what we need. We need to just find the angle of inclination between this line and the x-axis. So to find the angle of inclination, we have a formula for that. We simply say that tan of theta is equal to whatever the gradient of that line is. That's how to find the angle that that line creates for the x-axis. So the gradient is 3. So tan theta equals to 3. And then find theta. Theta is equal to, you're going to use the second function of tan on both hand sides of the equation. You can also see this at taking tan over. So it becomes the inverse, which is the second function. So we'll have 3, and then theta is finally equal to whatever shift tan 3 is on your calculator. So shift tan of 3 is equal to, and we're just going to round off to 2 decimal places. So that's 71.57 degrees. And that is our final answer. And that is it for question 8. Question 9 says, the diagram below represents a printed poster. Rectangle ABCD, this rectangle that we have over here, is the part on which the text is printed. The shaded area ABCD is 432 centimeters squared, and AD is equal to X. So let's mark that. ABCD is 4 centimeters from the left and right edges of the page. As we can see, 4 centimeters like that, and 3 centimeters from the top and bottom of the page. And the question is to show that the total area of the page is given by this. So they want us to find the total area of the page given the area of the shaded part and what the sides are. Okay, so with these sides, here is what we can see. They told us that this is X, right? So we can actually look at it as this, the dimensions of the page. This is X over here, okay? That would represent X. And then you can see that this is 4 centimeters from the shaded to the edge of the page. So we have 4 centimeters here and then 4 centimeters here. So this is X plus 8 centimeters. That would make up the length of the page. And then the width of the page would be this little part, which we didn't really call anything. We can call it Y or something else. But that, I guess I'll just call it AB. That part is going to be that plus the 3 centimeters, which would make up this part, that's 3 centimeters, and 3 centimeters on the bottom, okay, which makes up that part. And let's attempt to find this area, we're looking at the area right now. It's not a good idea because we don't know what AB is. So we need to find an expression for AB. And that's where the information that they gave us comes in. They told us that ABCD, the area of the shaded part, is 432 centimeters squared. Do you see that the shaded part has AB and X? So it means that for them to have gotten that area, they must have said X multiplied by AB to get that. Okay, so we know that that area is 432. So 432 equals X multiplied by AB. And we just needed an expression for AB so we can actually work with that. So to get AB on its own, you can divide both hand sides by X, and therefore AB equals 432 over X. And there we go. Okay, so we've got an expression for AB now. And now that we have this is just 432 over X. We can finally find the area of the entire page. The entire page is X plus 4 centimeters and the other 4 centimeters. Okay, that's the length of the page. And then the width or the breadth is going to be 3 plus 3 and then AB, which is 432 over X. Okay, so the area of the page would be equal to, we'll take all of that, which is 8 plus X. So we can say X plus 8. And we're going to multiply, that's the length. We'll multiply it by the breadth, which is 6 plus that. Okay, so that's going to be, we can just start with the thing with X. Okay, so 432 over X and then plus 6 centimeters. So that's length times breadth. And now we can see this is in terms of X. So this is the area of the page in terms of X is equal to, and let's distribute. So we multiply here. What will happen is you see that the X and the X would cancel because you're saying X times 432 over X. So the X's cancel and you're just left with 432. And then they multiply there, and that's just going to be positive 6X. And then multiplies to this. So what's 8 times 432? That is going to be 3, 4, 5, 6. But remember, it's 8 times 432 over X. So over X. And then lastly, 8 times 6 is 48. So this is what we have. So A of X is equal to, and we'll just add our constants together. Let's just look at how they wrote it. So they put the 3, 4, 5, 6 first. So that is 3,456 over X plus 6X. And then these add together. So that's going to be a 10, a 7, 80, 480. Okay, plus 480. And that is our answer. That is the area of the entire page in terms of X. Question 9.2 says, determine the value of X such that the total area of the page is a minimum, but you just need to determine the value of X, not the actual minimum area. Okay, so the value of X such that the total area is a minimum. Okay, so you can kind of see this as it's the same idea of when we have a turning point. So we can have, let's say, concave parabola, and you're trying to find out what its minimum value is. So at this point, this is where it is stationary. It is no longer increasing nor decreasing. So this is where the gradient is equal to 0. And we know that to get the gradient of this function, we would derive it. So that's really what we're going to do here. We have A of X, and we're going to derive that and set it equal to 0 to find out what that minimum is, or really the X value at which it will be a minimum. So we'll say A prime of, well, we're not ready to derive yet. Do you see that the X is still in the denominator? It needs to move to the numerator so that you can properly derive. So this is going to be 3, 4, 5, 6, and then X. And when you move it up to the numerator, the exponent becomes negative. And then plus 6X plus 480. Now we can derive. So A prime of X is equal to coefficient times exponent. This will be negative 3, 4, 5, 6X raised to the power of exponent minus 1, negative 2. And then plus 6. The X falls away because of 1 minus 1, giving you 0. Anything to the power of 0 is 1. Okay. And then the constant also falls away because the gradient of a constant is 0 because it is a flat line, a flat horizontal line. So we set the derivative equal to 0, and this is still this, but we can just take this opportunity to bring that x down to the denominator again. Sorry, that is a 6 over x squared and then plus 6. And then we can take this over since it's negative. So it becomes positive 3, 4, 5, 6 over x squared equals 6. Okay, to solve for x, we can cross multiply. So that's going to be 6x squared is equal to, and this 3, 4, 5, 6 will multiply with the natural denominator of 1 here. So that's going to be 3, 4, 5, 6, and divide both hand sides by 6. X squared equals 576, so 576. And then you see that we have to find the square root. Okay, so square root both hand sides, but this is an equation, so we have a positive and negative solution. And x is equal to, now here's the thing, you see x here and what it represents. X is the length, okay? It is the length of this side, which you can see is not negative. So we're going to use the positive answer, okay? So square root of this number, and we're only going to consider the positive. And this means that x is equal to 24 centimeters, okay? Regardless, they were both going to be, x is either 24 centimeters or negative 24 centimeters, but we're going to take the positive. Okay, so that is the last question for question 9, and that is our answer. Question 10.1 says, A and B are independent events. Okay, the probability of A is 1 over 3 and the probability of B is 3 over 4. And we need to determine the probability of A and B. Okay, so from independent events, we know that if events are independent, then the probability of A and B is equal to the probability of A multiplied by the probability of B. So this is going to be equal to 1 over 3 multiplied by 3 over 4. And then from here, you see that 3 and 3 will cancel and you'll just be left with 1 over 4. And that is our answer. Question 10.1.2 says, we need to calculate or determine the probability that at least one event occurs, at least one. So we only have 2 events here, okay? And they say the probability that at least one occurs. To interpret this, this really just means that either A could occur or B could occur. And that's really what they want. They want the probability of A or B. So this is what we have to find. Now, the calculation for the probability of A or B is the probability of A plus the probability of B minus the intersection. And the reason we subtract that intersection is because if we don't, it ends up being added twice. It has to do with really the Venn diagram. If you have A and B and you say the probability of A, everything here, plus the probability of B, everything here. You see, the problem here is that you already added the intersection. The first time we said the probability of A, it included that intersection. But then you said the probability of B, and it also included that intersection again. So we have to subtract by that intersection so that it can only include one of it. That's the whole point of that. Okay, so this is equal to, and we have these calculations. We have A and B over here. Okay, so A is 1 over 3 and B is 3 over 4. So plus 3 over 4 and then minus 1 over 4. And that would be our answer. So let's see. Okay, just to save time, we put that on the calculator and that is 5 over 6. And that is the probability that at least one event occurs. Question 10.2 says, the probability that it will snow on the Drakensberg mountain in June is 5%. Okay, so probability that it will snow is 5%. Then they say, when it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees Celsius is 72%. So this is when it snows. On the condition that it snows, the probability that the temperature is going to drop below 0 degrees is 72%. So when they're giving us this type of information, if it snows, then this is the percentage that it's going to snow. Because it's a situation where they're showing you that the probability that it will snow is 5%. So you know that the probability that it will not snow will be the difference, which is 95%. And then they're saying if it snows, okay, so just say 95% and then say not snow. And then they're saying when it snows on the mountains, the probability that the minimum temperature is going to drop below 0 degrees is 72%. So this is the probability. The condition that they're referring to is the temperature dropping below 0 degrees. So when it snows, we're going to follow the branch where it snows. And now they're telling us that the probability that it drops below 0, so we can say below 0, okay, is going to be 72%. And so we'll be able to find the probability that it will not drop below 0. Let's just call this below Z, okay? And then not below Z, okay? And yeah, that will be the difference, okay, which would be 28%, okay? Okay, so I've just decided to change that 0 degrees to an actual 0 degrees. And then we have, if it does not snow on the mountains, that's the not snow part, the probability that the minimum temperature in central South Africa will drop below 0 degrees is 35%. So on the condition that it does not snow, the probability that the temperature will drop below 0 degrees, okay, so that is below 0 degrees. The probability of that is 35%. So if this is 35%, then it means that the probability that it will not drop below 0 degrees would be the difference, which would be 65%. Okay, so not below 0, 65%. Okay, because that's what will help it add up to 100%. Okay, so yeah, they say represent the given information on a tree diagram, clearly indicating the probabilities associated with each branch. These are the probabilities associated with each branch. They didn't say anything about stating the outcomes, so we'll leave that. And this is our answer. Question 10.2.2 says, calculate the probability that the temperature in central South Africa will not drop below 0 degrees in June 2024. Okay, so we're looking for the probability that it will not drop below 0. Notice the places where we have not below 0. That's here and that's here. So we're going to take the full probabilities. This has a lot to do with the outcomes. When you're looking at the outcomes of everything, you're going to look at them across their branches. So the outcomes that we'll have here. So we'll have a situation like this, where we can say the probability that it snows is 5%. And then given that it snows, the probability that the temperature will drop below 0 will be 72%. So the outcome we'll have here is it snows and the temperature drops below 0. And we could find the probability of this simply by saying that 5%, which is 5 over 100, multiplied by 72%, 72 over 100. So we just multiplied their outcomes. Now we could multiply each and every outcome, but let's actually just stick to what they want. They want the probability that it will not drop below 0. So we're only going to look at these ones. So you see this not below 0, it was the result of if it snows, the probability that it will not drop below 0 is 28%. We're going to have to put them together because they had a single outcome. So that is the probability that it snows and the temperature does not drop below 0 degrees. So that will be not below 0. We'll take that, okay, and that you can see is going to be 5%, 5 over 100, multiplied by 28 over 100. And then the second place where we see not below 0, because we're going to just take all the places where not below 0 occurs. And that will be over here. So this is when it does not snow, probability of not snow, okay? And again, the temperature does not drop below 0. And we would just find out what that is. So this was 95. I don't know why I said 9.5. 95%, 95 over 100 multiplied by 65%, which is 65 over 100. So we are going to take these and we're going to add them, because that would give us the total probability that the temperature will simply just not drop below 0 degrees. Okay, and now that we have that, we're going to add these together and that will give us our answer. And the answer is, we can just put this in decimal form. So it's a long answer. I would actually leave it as a fraction. It is 1263 over 2000. Okay, so that is our answer to 10.2.2. Question 10.3. 10 learners stand randomly in a line, one behind the other. 10.3.1 says, in how many different ways can the 10 learners stand in a line? Okay, you just have 10 learners, 1, 2, 3, 4, so 10. And we're just seeing the different ways that they can stand in this line. So the first learner has 10 different places to stand. They can either stand here in position 1 or 2, 3, all the way to the 10th position. Once the first learner is standing, the second learner has 9 more places to stand in. So 9 choices. And then the third learner, 8, then 7 choices, 6, 5, 4, 3, 2, and 1. So you can see that to find this is simply 10 factorial, which is equal to, so this is 3,628,800 ways. Okay, so they said in how many different ways, that would be the total ways. Okay, moving on to the next question. And the last question says, calculate the probability that there will be 5 learners between the 2 youngest learners in the line. So let's keep in mind that at the end of the day, we need to find this as a probability. Okay, that there will be 5 learners between the 2 youngest learners in the line. Okay, so it means the 2 youngest learners are 2 specific people. And we can just look at the placements and how they can be standing. So youngest learner, we can call them youngest learner 1 and youngest learner 2. So youngest learner 1 could first be in the first position. Let's just remember that there are 10 places. So the first youngest learner could be in this first position. And then there needs to be 5 learners in between. So 1, 2, 3, 4, 5. And then the second youngest learner can be here. Okay, youngest learner 2. So looking at it like that, and then, we're going to have the other learners behind here. We're going to have to look at all the placements that we can have. It's not really the type of question where we can say, okay, we're going to ensure that there are 5 learners here, because these are not 5 specific learners. They didn't name 5 specific learners and say that these specific 5 learners need to be in between the first youngest and second youngest learner, or the 2 youngest learners. So we need to also consider that they could be anyone. It could also be a learner that is currently here that could be seated here, as long as there are 5 learners in between them. Okay, so looking at these placements, we could have it looking like this. Or another way that they could be placed would be like this. So in this case, youngest learner 1 could sit here instead. So instead of this learner being here, or any learner really, doesn't have to be that particular learner, youngest learner could be there, the first one. And then the second one, there has to be 5 learners in between them. So second way that could also happen would be like this. And then another way that they could be seated would be where you have 1, 2, 3, and that youngest learner is in the third position, this one of the youngest learners. And then again, you would have 1, 2, 3, 4, 5 places where you have 5 students in between them. And then there is the other younger learner. So see how you had 2 learners behind here? Now you just have 1. Okay, so like that. And then there's one more way they can be seated, because we need to ensure that they occupy places that allows for 5 learners to be in between them. So that would be one learner here, another one here, and I know I didn't put circles for them. There are learners sitting there. So, and then another learner here, then one of the youngest learners here, and then 5 learners in between them again, and then the other younger learner. So in this case, there would be no learner behind them. So that would give you a total of 10 learners standing again. So you can see from this that there are 4 ways that they can be standing like this. So for us to achieve this first placement, here's the thing. These 2 learners, they never said that one of these learners specifically has to be in front of the other one, has to be ahead of the other one. No, the first youngest learner and the second youngest learner, they don't have to be seated specifically like this. For example, the second youngest learner could be here and the first one could be here. So looking at their placements and where they are seated, it means that there are 2 ways that they can be sitting like this. Yes, they have 5 learners in between them, but youngest learner 1 could be in the first position and the youngest learner 2 could be in the 7th position, or youngest learner 2 is in the 2nd position and youngest learner 1 is in the 7th position. Okay, so that could happen as well. So there are 2 ways that they can be sitting like that. Okay, so we're done with them. And now let's think about the rest of the students. How could they be seated like that? Remember that these are not 5 specific learners. It could be any of these learners. So this learner, for example, could be here, or this learner could be here. So because of that, we can look at them as a placement of their own. There are a total of 8 other learners left. So the ways they can be seated is like this. This first learner has 8 different places to sit. You can either sit here in the 2nd position, the 3rd, 4th, 5th, all the way to, I won't call that the 8th because this learner is here. But they could be seated in any of these positions, and they happen to be 8 positions left after these 2 learners are seated. So that would be 8, okay? And then we have, after the first learner is seated, the second learner, okay, out of the 8, has 7 more positions to sit at. After that learner is seated, the third one has 6 more positions, and then 5, 4, 3, 2, and 1. So that is 8 factorial. So to find the total seatings, what this would look like, it would be 2 times 8 factorial. And then looking at the second placement, again, these 2 learners, the first youngest and the second youngest, supposing that they're not the same age, they don't have to be seated like that. Okay, so they have 2 total ways to be seated. And again, do you see that the total learners left will be 8 learners? And these 8 learners, this first learner has 8 different positions they can sit at. You can sit here, you can sit here, 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 and that will be a total of 8 positions. Once seated, the next learner will have 7 places to sit at. And once that learner is seated, the third one out of the 8 will have 6 more positions. So that's again a case of 2 times 8 factorial. And then as you look at the other placements, it's the same thing. These 2 learners do not have to sit here. They could sit as Y2 and Y1. So again, it's 2 times the remaining amount of learners. They have 8 different positions to sit at. That will be times 8 factorial. And then again, that's 2 times 8 factorial. So you have 4 sets of this going on. And so to find that, the total ways at first, we'll say 4 multiplied by 2 times 8 factorial. And let's go ahead and find out what that gives us. So that is 322,560 ways. Okay, but this was not the question. That's not the final question. The question is to calculate the probability that there will be 5 learners between the 2 youngest learners. We see the total ways that there can be 5 learners between the 2 youngest learners. So the probability must be over the total, the unrestricted total, which was in question 1. Okay, there are 10 learners in total. If we were just finding out all the ways they could be seated, it was this 3 million and that. Okay, so we're just going to take this answer and divide it by 10 factorial, or that 3 million. Okay, so the probability that we'll have 5 learners between the 2 youngest learners would be that answer over the total ways that they can be seated, which just simplifies to 4 over 45. And we can leave our answer like that. I prefer leaving it as a fraction. Okay, and that is our answer. And that is the last question for question 10. Okay, so that is it for this paper. Hope you guys enjoyed it, and I hope to see you in the future videos.